Good afternoon. Welcome. My name is Dave Cloudemacher. I lead security at Google for Android, Chrome OS, and Play. And welcome to our talk, Beyond the Myths of Android Security, here at Cloud Next. Great to see some familiar faces in the audience. Jay, nice to see you. Tamara, Dave. So to start out, I want to first tell you a little bit about the team of Android Security. What we do can be broken up broadly into three categories. One, Google Play Protect. These are the technologies that help defend against internet-borne threats, malware threats. It's also the tools that help users and businesses make better decisions about their security. So it's the user experience around security as well. Second big area of investment for Android security is in platform engineering. These are the core operating system capabilities, anti-exploitation, OS hardening, things to make Android a more secure operating system. And then the third area is SDLC, Security Development Lifecycle, which are the programs around ensuring a consistent high level of quality for security and privacy across the full Android ecosystem. And the other really cool thing about working at Google and in security is that we have just an amazing, talented team of technologists that honestly could be working on anything. They could be working on the latest cool blockchain technology and AI and who knows what, gaming. Instead, they choose to work on security and privacy because it's all about protecting people, users, and businesses. And at Google, when we have 2 billion devices and users, it literally is a war against evil. We're on the front lines, and it's a passion for all of us, and I'm really proud of that team. They're awesome. So what are the myths? There's myths around the levels of risk related to platform vulnerabilities, malware risks, and fragmentation. Fragmentation is like this new F word about like the differences in devices and the levels of patching and all that. I actually like to think of a different F word, a more positive F word, which is freedom. And that's the freedom of choice to select any device you want. And if you think about the history of Android and where it's come on its path for security, in the early years leading up to, if you think about letters of Android, each major release has different letter. So if you think about up to like KitKat K, this was all about building a great API, great platform for all kinds of apps. As we got through from L to N, LM and N, security became a huge focus. Now, Android always had a good security architecture, but it wasn't really the top priority until we got into that time frame. That was about 5 years ago when the investment in security really became a top priority at Google. And in around the MN time frame, Android achieved parity with any mobile platform. And I speak from experience on that score. I used to work at BlackBerry before I came over to Google. And at N time frame was really the area where security has achieved that level of parity. Now in Oreo, O, and soon to be released P, Android has really taken a leadership position in security. And we'll talk a lot about why that's what this is called, a deep dive. So at a very high level, it's one thing for me to stand up here and say, well, you know, security has really gotten better. We're working really hard at it. But we're always looking at ways to find independent measures of success. And I'd like to point you to a Gartner report that was published in December. It's an annual report called Mobile Operating Systems and Device Security, a Comparison of Platforms. I'm sure many of you are Gartner subscribers. So if you subscribe, go look at this research report. The Gartner analyst evaluated mobile security across 28 categories in the area of platform operating system security, as well as manageability for security. Android, Oreo, on the Pixel device specifically, had 24 strong ratings. And the other mobile platform had about half that number. And I think that might be a little surprising to many of you. And so, again, recommend you read that report. It's a nice high-level view of Android security, especially in the enterprise today. So let's talk about vulnerability risk. To really defeat the attack vectors out there, it starts with leveraging hardware, device hardware, properly. Prior to P, so prior to Android P, we had just as just a sampling. This is not everything that we've done in leveraging secure hardware, but this is a number of different items. We have leveraging the trusted execution environment, which is a hardware-protected area for hosting very security-sensitive operations outside of the main Android operating system and kernel. We can validate and verify credentials, pins, in that trusted execution environment so that it is more secure. We can prevent a rollback to operating system versions that might have vulnerabilities. You cannot roll back part or an entire operating system image. Verified boot, of course, verifying that you have an authentic image running on your device. Data encryption, of course. And key attestation, which was introduced in Oreo, enables an enterprise or anyone else to validate that, indeed, this device that is connecting to my service has running a known good version of firmware that meets the right kinds of security requirements. So key attestation is an important new feature leveraging secure hardware. In Android P, as I mentioned, we announced this at Google I/O. We're about to release it. There's some great new features. I'm going to talk a little bit in more detail about protected confirmation and StrongBox keys. But beyond that, we've added the ability to protect biometric checking in, again, the secure hardware area. Keys that are bound to the lock screen so that when you unlock the device, you have access. When you lock your device, the keys go away, and so your data is completely unavailable in the system. User presence required keys, so when you press a button, it validates that, yes, the user is there, but that validation happens in secure hardware. And then firmware transparency. Firmware transparency is kind of like verified boot on steroids. The idea is not only do I want to know that it's running some authentic version of Android, it is a specific digital signature that matches an expected version. So if you want to know it's running version whatever on this particular Samsung device or whatever, you have the exact firmware signature, and it's transparent so that an enterprise or a consumer or any other entity that wants to know that this device, again, connecting to my service, is running not just a verified firmware, but a specific known good signature. StrongBox keys. So this is a really interesting mobile first. Some of you may have heard of the concept of a secure element. This is a special microchip. You find them in your credit cards. They're in SIM cards or special kinds of digital technology. What's really interesting about a secure element, it protects against certain kinds of physical attacks, invasive or non-invasive physical attacks. So the keys, the cryptographic keys held in a secure element are ultra secure against any attack. Up until Android P, there hasn't been a mobile device, a popular mobile device operating system that supports the use of a secure element-backed key through APIs. And with Android P, you can now create a key called a StrongBox key that is backed by a secure element. It's tamper-resistant. It protects against the most advanced physical attacks. And so you cannot extract the key from a device that supports a StrongBox key. Another feature that is really exciting is protected confirmation. So I mentioned the trusted execution environment. It's this separate hardware compartment that allows you to execute really critical software that runs outside of Android, the main operating system, so that even if Android, the kernel, is compromised, even at the lowest levels, you still can assure the integrity of that execution environment. So trusted execution environments have been around for quite a long time. Almost all the devices that are in your hands. By the way, how many people are using Android here or planning to use all of you? Oh, my job is done. OK. Oh. That's great to see. So the trust execution environment has been around for a long time. But what we're doing is we're leveraging it in a really unique and exciting way. The idea here is we're adding the ability for the user to interact with the trusted execution environment. So input and output can be controlled with this secure compartment. So now when you have a very high value transaction, the user can be presented with an additional level of confirmation that says, did you really mean that? Did you really mean to pay that amount of money? Or did you really mean to log into my enterprise service? And then that confirmation by the user, pressing that button, is actually validated and digitally signed in the TE. That trusted UI is what we call it as a general technology term. Trusted UI has never been exposed in any major mobile operating system API before until Android P. So you get your trusted UI now in TrustZone. So one example of this is we've partnered with a number of companies who are looking at launching, taking advantage of this new API and this new technology. Duo Security is an enterprise security company who's leveraging protected confirmations to improve the security of the second factor authenticator. So you log into your Chrome website and you have two-factor authentication turned on. I hope you all have two-factor authentication turned on all your web services and all your enterprise apps, of course. And then you want to use a hardware token as your second factor. It would be nice to use your phone as a second factor, right? But in this case, the prompt comes to your phone. The Duo app actually sends the information about your login into this protected area. The user says, yes, indeed, I'm trying to log into this particular service at this particular time, presses the button. All that information is never exposed to the main operating system. It's digitally signed with a key that never leaves this hardware protected area, and then sent to the enterprise that can now validate that, yes, indeed, it really was this user, and I have much more higher confidence in that authentication than I could ever have had before. Another really interesting use case is in the medical domain. Today, we do not allow our mobile devices to be used in controlling a life-critical medical device. This is just not done today. So if you are a patient, a person with diabetes, you want to remote control your insulin pump. You have to have this obtrusive, very expensive remote control. With Android protected confirmations, we can now actually have an app that does that. However, when you use the app, the confirmation, like am I going to actually inject 2 insulin units into my body, that data is validated using protected confirmations using this graphical interface that you see on the screen. So it's a secondary confirmation, all happening completely outside of the main operating system. So when you validate it, your insulin pump now knows it can have higher confidence that this transaction, life-critical dosage of insulin, was not tampered with. So for the first time, we can start to break through the ceiling of assurance in mobility that we just haven't been able to break through up until now. So it's really, really exciting. So of course, process isolation in the operating system has always been very important. Sandboxing applications from each other and from the operating system kernel. Lots and lots go into that. SE Linux forms the foundation of Android's security controls that prevents applications from accessing resources that they should not need. So the principle of least privilege is enforced through SE Linux. Of course, we have the Java sandbox. We have Linux's basic process isolation model. We have many, many other sandbox capabilities. Each application only has access to the system calls it needs and no more. So we do syscall filtering, which is another form of sandboxing. And on and on. There's tons and tons of these isolation and sandboxing capabilities that all prevent an application, even a rogue application, from doing things it should not be doing and adding risk to the rest of the system. Now, in the enterprise context, one of the really unique aspects of process isolation and sandboxing applies to how we handle the separation between the personal environment and your business environment. So of course, in the enterprise context, we see a lot more BYOD or COPE, corporate owned, personally enabled. So regardless of your purchase model, you have your personal side, your personal apps, and you have your business side and your business apps. How do we keep them separated? Actually, to the best of my knowledge, Android and Chrome OS on Chromebooks are the only 2 major operating systems that have this built-in concept in the operating system that to separate these concepts. So if you look at the world today of popular operating systems, they're the only 2 that I know of that actually build the process, the isolation sandbox between this personal domain and this the enterprise or business domain. And in Android P, the newest release of Android, we've made the user experience a lot nicer in terms of knowing which apps are personal apps, which apps are business apps. So you have this great tab view. It's maybe hard to see on the screen here, but you can see the personal side tab and the work side tab, so it's much easier to know which apps are personal and business, and that's just a much better user experience, much safer user experience. Another really important trend in mobility, and including especially enterprise mobility today, is sort of digital well-being, being able to unplug, when work is over. That's a really important thing for us to be able to try to do a better job of. And with Android P, it's much easier now to toggle off that work profile. It's a simple control, and it's clearly labeled, and it's just really easy to just unplug and turn off the work profile when you're done with it for the day. Of course, protecting data in transit, always important for enterprises. Android has supported VPN services for a really long time. There's a couple of new additions, again, in Android P in the latest release. By default, all applications have to have TLS. If they're using web services, they have to use TLS by default. So we changed the default. It's challenging when you have millions upon millions of apps and developers to make that transition. And we've had TLS support for a really long time, but changing it to the default. There's also a recent announcement this week about Chrome's defaults for HTTP, TLS being turned on and enforced by default. So this is a big trend in computing, and it's really great that Android has that on by default now with Android P. Another feature, DNS over TLS. You may have heard of DNS hijacking. How do you know you're talking to the website you think you're talking to? And how do you know that your ISP is not maybe eavesdropping into the web addresses or the websites that you're surfing? And so DNS over TLS is a new standard for protecting the privacy of your communication to the DNS server. And again, another Android first. I might sound like it's kind of repetitive with a lot of firsts, but this is a first, again, in mobile operating systems, supporting DNS over TLS. And there's also some great stuff about certificate pinning, improvements there in Android P as well. So we leverage the secure hardware. We have process isolation and sandboxing. This is fantastic stuff. But sometimes an app might find a way out of the sandbox and try to attack the kernel. Can we protect against exploitation of the critical parts of the operating system? And this is really critical because, and this is a really important principle that I think is one of the part of the myths out there, which is that if you have a bug, that if you have a vulnerability, and there are going to be those in every sophisticated software product in the world, there's going to be some bugs and some vulnerabilities, doesn't mean that that bug can be exploited to do harm. That's the key. Bugs not equal to exploit. And it's all of this defense in depth I've been talking about, and especially these anti-exploitation mechanisms that enable us to prevent a bug from being converted into an exploit. Examples are address space layout randomization, ASLR, common anti-exploitation mechanism. Some of you may have heard of stage fright. Stage fright, probably one of the most infamous vulnerabilities of all time. It was actually the vulnerability that launched many of the major Android security programs, the regular patching updates that we've been doing month after month, with complete and total reliability for several years now. That all was launched on the back of stage fright vulnerability. To this day, we do not know of any actual practical exploit of stage fright. Even back then, up until now, we don't know of a single one. So there are proof of concept code, but to leverage the proof of concept to actually exploit the system requires getting past ASLR and a bunch of these other anti-exploitation techniques. And to this day, we still don't know. Now, it doesn't mean it's impossible, because you never know if there's something you don't know. But we have pretty good visibility when you have 2 billion devices and our connections to the research community, the most sophisticated researchers, including Project Zero and others around the world, and we just have not heard of this exploitation. Again, this doesn't mean that exploitation doesn't exist. It means that there may be a little bit of a mismatch in sort of perception in terms of bug not equal to exploit. So ASLR is important. Kernel version of that as well, KASLR. Hardened user copy, we validate the parameters when we go into kernel calls and make sure that we don't access memory inappropriately. Fuzzing, we're working really hard on infrastructures for fuzzing because attackers and researchers often use fuzzing, throwing random inputs at different parts of the operating system to find vulnerabilities and try to exploit them. And so we run lots of our own fuzzing infrastructures to prevent. So we know about them before anyone else does. Other kinds of sanitizers, integer overflow sanitization, control flow integrity protection. There's lots and lots. I could speak for hours about all these, but there is just a ton of defense in depth in making the operating system itself very difficult to exploit. And so, again, this all sounds great, defense in depth, lots of stuff, but how do we measure success? We have these anecdotal evidence of being difficult to exploit certain well-known vulnerabilities. That's great. We actually talked to some gray hat hackers, and we asked them, what's the price of a scaled exploit on Android? And we hear numbers like $10 million and very high numbers. But we actually think that one interesting way to measure success and the ability the ability of Android to protect itself against exploitation is in the cost of an exploit. So there is as you can imagine, a very robust market for purchasing exploits on Android. And so researchers and other attackers develop exploits. And they try to sell them, in some cases, to the highest bidder. We have our own Android security rewards program. So we try to encourage researchers to bring their research and sell their vulnerabilities to us. And so you can look at things like our own rewards program on the left, and you can see that the price of exploits is actually higher on Android than other mobile operating system platforms. And if you look in the middle here, mobile pwn to own is another example of where you can measure the price of these exploits, the market pricing. So elite hackers can go to these contests and try to land their exploits. And year after year, we're seeing the price of those Android exploits going higher and higher. In the last one, late last year, pricing was pretty much on par between Android and other mobile platforms. And actually, at the last mobile pwn to own, there were no core Android platform exploits that were landed. And I can't say the same for other operating systems that did have exploits landed. Again, it doesn't mean that the exploits don't exist. What we're looking at is, overall, what does the data show in terms of the general exploitability? And you can see these clear trends, but if you look at the pricing. Forensics, again, we see lots of devices, billions of devices, so we get some visibility into what's actually being attacked and how malware is trying to leverage vulnerabilities. I mentioned stage fright. There's a couple other there on the screen, other sort of well-known vulnerabilities. And even before even before patch, the number of exploits it's infinitesimally small and essentially non-existent for these well-known exploits. And of course, after public release, post-patch, we haven't seen any on these well-known exploits. So again, there might be a little bit of a mismatch between perception and reality. The key is there are bugs, there are vulns, but that doesn't translate to exploits. It doesn't translate to risk for users or businesses. Let's talk about malware risk. So first of all, one thing that's really important to understand is that malware, so when you have global scale app stores with hundreds of millions or billions of users, there's going to be malware because it's really attractive target to go after, to publish an app that will just fish for your credentials. It's very easy to throw up a window to ask for your password. So that means there's going to be malware on any platform. And so you can see here that there's been some recent research on other mobile platforms showing the increase in malware across those platforms. This was a report done by Symantec showing iOS malware. I just noticed this last week. Talos, the Cisco research division, found these targeted malware attacks on on devices in, I think they were in China. No, sorry, India. Targeted attacks against Apple devices. My point here is that there's malware. So what do we do about it? You have to build malware protection into the operating system. Seems pretty obvious. You just have to have that, because when you do find something malicious, you don't want to let it sit there on the device. You want to get it out of the app stores, and you also want to get it off the device, regardless of where you get those apps from, whether they're coming from a well-known app store or from some other source. You want to be able to remove that. Microsoft figured this out with Windows Defender. Chrome with safe browsing now running on 3 billion devices. Part of the platform. Part of the Chrome platform. On Android, Google Play Protect, part of the platform. It's really important that malware should be built into the operating system. So today, Google Play Protect actually is, for an operating system threat defense solution, it is the world's most widely deployed antivirus solution, with more than 2 billion devices being protected, 50 billion apps verified each day. And so, again, really proud of my team that works on the security engineering. We're working on applying ML. I know it's a buzzword, but when it comes to defending against internet threats, it's huge. Because a lot of times, malware changes its attack vectors and how it works. And ML enables us to find those new attack vectors, the real-time attack vectors, in ways that a static analyzer or a dynamic analyzer simply can't do. And so we're obviously leveraging Google Brain, DeepMind, and the deep expertise of Google AI in this mission to protect users and businesses. We're also working to ensure that developers are learning more, getting more visibility into the security vulnerabilities in their own apps. And so we've launched this Play App Security Improvement Program. Google has some of the world's leaders in program analysis. So this is like, how do you understand the control and data flow in a program? And we use that program analysis expertise to actually find security vulnerabilities and alert the developer of vulnerabilities in their apps so they can fix them. So 90,000 developers have now addressed vulnerabilities using this program on 275,000 apps and counting. We can see here that Google Play Protect, it's really making a huge difference. You can see the graph going down. The green line are the instances or the rates of malware infection on devices that load off of Play. And the blue line, already really low and still going lower, are the malware rates on Play. You can see there's still about a factor of 10 between the two, meaning that Play is still the safest place. And one of the reasons why is because the malware tools, the malware technology actually looks at not just the app, but the developer. We know a lot about the developer and their history and a lot of their other characteristics, so we can do a much better job because of that information. So it always will be better on Play. But we're dedicated to improving the security and privacy of users regardless of where they get their apps. And you can see it's it's gotten down to the point now where here in 2018, the odds of the average user like downloading malware from Play is about the same as getting struck by lightning. And so there's some misconceptions there in terms of the malware rates. It's gotten very, very low, and we're not resting on our laurels. Don't worry, we're constantly improving this technology, but things have really, really gotten quite good. Let's go back to the F word, fragmentation. You may have heard of Project Treble. So originally launched in Android O, Oreo, and extended in Android P. The idea here is we've increased and improved the abstraction, the hardware abstraction layer between the Android operating system and the device-specific implementation, essentially the porting of Android to different devices. And we've made that interface much better, more rigorous, and with just a better abstraction, which enables a device manufacturer to modify or change the Android system without necessarily changing the device-specific portions. This enables them to upgrade to new operating system versions more easily. And so you can see that picture before. The difference between operating system and firmware was somewhat, there was abstractions, but not really rigorous across the whole system. We've really worked extremely hard to improve that interface, and that's what Treble is. The impact of that is in Android P. You saw this with our beta release. Far more OEMs were able to upgrade and are going to be upgrading to Android P from O, Oreo, than they were from N to O, faster. So faster out of the box because the Treble interface has made it easier to upgrade. Overall, security patching has improved a lot. Again, we're not satisfied by any stretch, but last year we had about a billion devices receiving security patches. A billion devices. It's about 30% more than the previous year. And we've actually worked to include in our agreements with OEMs security patching. So we believe that these new patching programs will dramatically increase the number of devices getting these regular security patches. Now, how do you know, especially as an enterprise user or as an IT security professional, how do you know which Android devices are actually getting the regular patches? So we think this is important to have that kind of transparency. And so we've created, a few months ago, we launched the Android Enterprise Recommended Program. And what this does is a set of requirements that make it really clear which devices are meeting these enterprise-grade requirements. So it's actually much more than just pure security features. It's things like supporting zero touch, which is a really important usability feature for Android enterprise deployments. But the regular security patching is a very important part of the recommended program. So people, generally speaking, most IT shops know that Galaxy flagships and Pixel devices are getting these regular patches. But when you get beyond that, it's not as clear. The Android recommended program is now a place you can go to and see which devices are meeting those requirements. So I mentioned earlier that there's the F word for fragmentation. I prefer the F word for freedom. And this is an example of that. In the Android Enterprise Recommended Program, these are all the devices. I don't think this is the complete list, but this is like an example of many of the devices that today are listed in the Android Enterprise Program. And so if you're in the enterprise and you're looking for particular sets of features for your users, different kinds of price points for your users, Android Enterprise means choice. That's the message here. One of the things that I'm really proud about with Android and our approach to operating system security is the openness and the transparency. And we have a lot of defenders because of that. Because it's an open platform, if you think about the kinds of organizations that work each and every day to help protect Android security, it's really awesome. It's amazing. And it's not just at Google, it's not just my team. At Google, we have identity security professionals. Our corporate security people are awesome. I mean, they set a very high bar and very stringent standards. I can tell you, again, from working in the enterprise space for quite some time, as sophisticated security as I have ever seen in any enterprise, and that's really great. It drives us to be better. It's the people working on cloud security, of course, here at Cloud Next. You've heard a lot about that. It's a massive team effort. Literally every day, thousands of security professionals wake up thinking about how to protect users on Google services. But on Android, it goes way beyond what any one company can do. You have the device manufacturers. Many of the device manufacturers have really good security teams, and they're partners with us in defending the Android operating system. The chip vendors, Qualcomm, Broadcom, MediaTek, and so forth. Again, tons of investment in Android security. The mobile operators, academic institutions. You know, security researchers really like working on open platforms. It is just a friendlier platform to do research on. That is no surprise. So we get a lot of great collaboration in the academic communities. Of course, independent security researchers, I mentioned the Security Rewards Program, has enabled us to develop really wonderful relationships with some of the world's best security researchers, again, all working to help defend the platform. And of course, Android is built on Linux. And we have the worldwide open source Linux community. So the power of open and the power of transparency is what really differentiates Android more than anything else. And that is a key part of the overall Android security strategy. So this is sort of the last sort of thing I wanted to really get across in this area of myths, and is really just get across some of the ethos, if you will, on Android security strategy. Openness. We fundamentally believe that transparency and openness breeds trust. And being closed, being secretive, breeds distrust. Now, there are some wonderful closed source platforms out there. I've worked on some myself in previous lives. And when you have a product that doesn't have any vulnerabilities and it's absolutely perfect, I'm not sure if that thing exists, but if it did, you could say, all right, well, it's closed, but it's doing a good job. But when you're getting vulnerabilities, when things are not working right, and you want to know why, as an enterprise especially, and you don't know, because the code is closed, the internal practices are closed, does that breed trust? I don't think so. I really don't think so. I think openness breeds trust. And so things like we publish our annual Android security year in review. That provides incredible amounts of transparency in where do we see the threats coming from. The exploit pricing I mentioned earlier, how do we see those trends? How does it differ geographically? Like, there's a ton of data that we want the community to be aware of, and so we expose that because we think that that kind of transparency will improve the overall security posture of the platform. And of course, again, the open platform means that the defenders scale better. Today's attackers, it is humbling and frankly scary sometimes when we see the sophistication of the attack threats out there. In my career, I've been working in security for 28 years. I have never been on the front lines of seeing those actual attacks anywhere else than I have at Google. Again, because we see so much of the mobile ecosystem. And they're determined. They are determined to do harm. And that defending against that kind of sophisticated attack requires a scaled defense. That's technology, scaled technology. Of course, we leverage the cloud to deploy many of our defenses. But it's also people. It's scaling people. And that's all about being open. Measurable security, a lot of what I've talked about here is about measurable security. I believe that one of the most fundamental problems and biggest problems in cybersecurity today is that we can't really measure. It's very difficult to measure how well you're doing, how well a platform is able to deliver on the security promises it claims. How do you measure that? That's a real problem. So another thing that we're really working hard on is developing these objective measurements of the system's ability to protect. So I mentioned exploit pricing. We're also looking at assurance programs. There are some government certification programs for mobile devices. They do some things. They test certain functionality. But they don't really get down into like the penetration testing, the vulnerability assessment. So we think we need to take that to the next level. And again, many OEMs are doing a good job of that. We want to more formalize that and expand that. There's lots of other examples where it's all about looking at the data and using data to inform how we do our job, but also to inform you of how well we're doing and how well you're protected. Measurable security is a very important part of our strategy. And as I mentioned earlier, leveraging all of Google and the amazing talent and technology across all of our divisions, cloud, G Suite, identity platforms, to make an end-to-end secure solution for Android users.